Hello, my name is Dave Putt, and I've been a beekeeper along with my son Doug for about 8 years now. And I am also an advanced master gardener, and I'm a Michigan conservation steward. Today I'm hoping to get you excited about possibly becoming a beekeeper yourself. Before we get into what goes into becoming a beekeeper though, I do want to spend some time talking about our native bees here in Michigan, and I also want to talk about the importance of bees, okay, and their role in pollination. So before we start with all the different types of bees that we have in Michigan, I just want to clarify a little bit about what is a bee and what is a wasp and what is a fly, because sometimes they can look very similar. And maybe you've been stung by a flying insect and you thought it was a bee, and more than likely it was probably a wasp. So in this first slide here, those top four insects are actually wasps. You see a bald-faced hornet in the upper left. To the right is a European hornet. Below that is a European paper wasp, and to the left is a common yellow jacket. And more than likely, if you've been stung, it's probably been by a yellow jacket or possibly a paper wasp. Now, bees have evolved from wasps, but there are differences. So at the bottom of the screen, I show just two examples of bees. And on the left is the honeybee, and on the right of that is a bumblebee. And even though there are very many similarities between wasps and bees, there are some differences you can look for. One of the first things you want to look at is the size of the waist, okay? A bee and a wasp, they have three major body parts. They have the head, they have the thorax, and they have an abdomen. And it's the waist, that little waistline between the thorax and the abdomen in a wasp is usually very thin, whereas in a bee, it's quite a bit wider. So that's one thing to look at to distinguish a bee from a wasp. And the other important thing are the hairs. Bees, except for a few bees, all bees have hairs, and they are actually forked hairs, and they aid in their ability to collect pollen. Whereas with wasps, they do not have hair. All right. So that's a couple things you can look for when distinguishing wasps and bees. What about flies? There are also flies that look a lot like bees too. And the picture on the right there on the slide is a picture of a hoverfly. Well, we also call them syrphid flies. And they're about the same size as a honeybee, and they look very much like a honeybee. But one thing about flies that makes them very different from bees and wasps is the number of wings. Whereas bees and wasps have 4 wings, they have both hind wings and forewings. Flies only have two wings, okay? Okay, so we already got into a little bit about bee anatomy. As I mentioned before, bees have 3 major body parts. They have the head, they have the thorax, and an abdomen. And then, of course, they have the hind wings and the forewings. Oftentimes it's difficult to distinguish the forewings and the hind wings because they are kind of clasped together. They have 6 legs, and it's usually the rear leg where the pollen is collected, even though the fact that the bees have these forked hairs, pollen can collect on just about any part of a bee where there's hair. They have a compound eye, and they have smaller eyes, two antennae, and they have strong mandibles, jaw parts, and they have a proboscis, or what is really a tongue. Okay, and these tongues that are what are used to lap up the nectar when they visit a flowering plant. Well, let's talk a little bit about bee pollination, because that's what makes bees so important to our natural environment and also to our economy. Because approximately 80% of all of our plants, that includes both agricultural plants and native plants. About 80% of our plants in Michigan are pollinated by one sort of bee or another. So now you understand the importance of having bees and pollination. So in this example here in this diagram, this is a picture of a complete flower, a flower that has both the male and the female reproductive organs. The male organs are the anthers, the stamens with anthers, and it's the anthers at the top of the stamens that contain the pollen. The female part of the flower is called the pistil, okay, and the very top of the pistil is called the stigma. So what happens is when a bee visits a flower, it comes in looking for either pollen or nectar, or both. And when it does so, it brushes up against the anthers, okay, the male part of the flower, and pollen grains stick to these forked hairs on the bee. Then when the bee leaves that flower and visits another flower of the same type, as it's going towards the anther, the pollen, in the other flower, it brushes up against the female organ, the pistil, and it deposits pollen on the stigma of the pistil, and therefore then fertilization then will occur. So that's cross-pollination, where a bee has transferred pollen from one flower to another flower. Bees can also transfer pollen from the male part of the flower to the female part within a flower, okay, and that would be self-fertilization. But they're very important for pollinating our flowers and for fruit production. Now look at the picture in the upper right part of the slide there, and you can just see there's a bee just covered in pollen, okay? But usually the pollen grains will be stored on the hind legs of the bee. We have over 3,500 species of bees in the United States. And just alone here in Michigan, we have more than 450 species. Most of our bees, though, are very different than the honeybee or a bumblebee. 90% of all bees are what we call solitary bees. In other words, they are not social insects where they have a division of labor among the bees, where you have queens and drones and workers. 90% of bee species are solitary, and they do everything on their own. Just an example here of just some of the families of bees that we have in Michigan. I listed 5 families here, and we're going to go through a little bit of some of the examples of some of these members. In the Colletidae, the ones we're going to talk about today are the Cellophane bees and the mass bees. In the family Adrenidae, we have mining bees. The Colletidae family consists of a lot of cuckoo bees, and I'll talk about cuckoo bees in a little while, and also sweat bees. The Megachilidae, those include a lot of different types of bees, such as mason bees, leafcutter bees, woolcutter bees, cuckoo bees, and resin bees. And then finally we get to the family Apidae, and this is the family of bees that we would probably be most familiar with, because this would include the honeybee, the bumblebees, carpenter bees, squash bees, more cuckoo bees, and digger bees. Let's talk a little bit about sociality in bees. We talk about, there are insects that are called social insects. And some of our bees are social insects. So are some of our ants, okay? So social means that there's more than one generation living within a nest at one time. In other words, the queen has laid eggs multiple times throughout the year, and those will hatch into new generations of bees. So that's a social bee species, and there's usually a division of labor. In other words, the queen has one job, the worker bees have another job, and the male bees have another job within the hive. Communal means that multiple females may share an entrance to a nest, but once they're inside, they independently build their own nests, and it's often called aggregation. And then finally we have solitary bees, which I mentioned before. 90% of our bees are solitary. And that means a single female bee is responsible for all the tasks that might be carried out by worker bees or male bees in a social beehive. So let's talk a little bit, first of all, about the cellophane bees and our mass bees. Cellophane bees are solitary. They're ground-dwelling. And most of our bees are actually ground dwellers. 70% of our bee species are ground dwellers. The other 30% of bees make their nests above ground. And some will do both. Some can make nests both below and above the ground. So in the case of the cellophane bees, they're ground dwellers, and they like bare soil. You're not going to see them making their nest in a grassy lawn. You're going to see them looking for large bare spots. And the reason they're called cellophane bees is because they have a couple of secretions that they mix together. One is they mix their saliva with another secretion from a gland on the abdomen, and it's a waterproof substance that they then line the hole of their nest with to protect their nest against water and so forth. Mass bees, the reason they're called mass bees is because if you look at the head of a mass bee, you can see it has a very large patch, a very large white or yellow patch, and those are mass bees. They're solitary. These nest above ground in pre-existing cavities, whether it be hollow plant stems, twigs, or burrows made by other insects like beetles. They are different. They are different than most bees, these mass bees, in a couple of respects. Number one is that they don't have hairs, and that's unusual for bees. So how do they collect pollen and nectar? Well, they do it by sucking it up, okay, with their proboscis. So they actually store the pollen and honey inside, and then they regurgitate it later, okay? They are smaller than a honeybee, okay? As far as pollination, bees can be specialists or they can be generalists. Some bees are very prone to pollinating certain types of plants. Some are not specific, they're not choosy what plants they visit and pollinate, and those are called generalists. I've listed for all of the native bees that we're going to talk about today, I've listed some of the plants that they frequently pollinate. And in this case, as you can see, cellophane bees and mass bees, they tend to be generalists. The cellophane bees are good at pollinating maple trees, willow trees, plum trees, blueberries. The mass bees are good at pollinating a lot of our native wildflowers, things like Canada anemone, our dogwoods, milkweeds, Culver's root, and goldenrods and lobelias. So they're very valuable bees for pollination. Well, let's move on to another group of native bees in Michigan, and those would be the mining bees. And mining bees are usually solitary. They're ground dwellers. They tend, unlike the cellophane bees, which like loose soil, the mining bees, they prefer a more compacted soil and well drained. They do collect pollen on their legs using the hairs on their legs, and they're about the size of a honeybee. And as you can see, they're very important in the pollination of a lot of plants, whether it be some of our native plants like bloodroot, pussy toes, wild geraniums, and then later some of our native plants later in the year. But also, they're very important for the pollination of fruit trees and berry plants. Things like blueberries, cranberries, cherries, strawberries, and elderberries, okay? They are a very important crop plant pollinator. Sweat bees. Sweat bees tend to be smaller than a honeybee, and it's a huge group. Many species, so not all of them are going to look like this sweat bee I'm showing you here. This is a green metallic sweat bee. And sweat bees are solitary, although sometimes they can be communal or even semi-social, which means that some sweat bees may have 3 generations a year. So the queen is laying multiple generations in the course of one single year, more similar to, let's say, the honeybees or bumblebees. They are ground-dwelling, or they may nest in rotting wood on the ground. The pollen is collected on their leg hairs. As I said before, they're small. They're usually smaller than a honeybee. Very important, okay, in the pollination of a lot of our native plants like wild geranium, coneflowers, and especially our aster family in the goldenrods. Goldenrods, more of a late summer, early fall plant, and the sweat bees are very important in the pollination of our goldenrods. Mason bees are solitary bees. They nest in cavities above or below ground. They like things like dead trees, especially plant stems, okay? And also they might take over nests that maybe were made by mud dauber wasps. They collect pollen on the hairs of their abdomen. On the bottom of their abdomen, they have hairs, and that is how they collect the pollen. And they're very important in pollinating a lot of our native plants, and also they're very important in the pollination of fruit trees, especially plum trees. Well, let's move on now to our leafcutter bees. Now, leafcutter bees are also a solitary bee. They live in cavities above or below ground. It's kind of similar to what we just said with the mason bees, okay? They like dead trees, pithy plant stems, or they may burrow into rock cavities or mud dauber nests as well. Now, here's the interesting thing about leafcutter bees, and this is why they get their name leafcutters, is because the females of the species are able to cut pieces of leaves. Okay, they're actually able to chew a portion of a leaf and then carry it back to the nest and line the inside of their nest with these leaf particles. Okay, and so it protects their nest from the elements, certainly water. They collect pollen on their abdominal hairs, and they're about the size of a honeybee. They're very general foragers. They're not picky. Well, these last two species, last two types of bees that I talked about, the leafcutter bees and the mason bees, you may have heard about bee hotels. Bee hotels are becoming more popular nowadays, and these can be homemade, or you can purchase these bee hotels. And the idea is that you hang them somewhere in your backyard, and they're used to attract bees. Well, what kind of bees would you expect to find nesting in a bee hotel? Well, it would be those last two groups I mentioned. It would be the mason bees and the leafcutter bees. More than likely, those are the ones that are going to be attracted to your bee hotels. And you can see in the picture there, this is a mason bee visiting the cylindrical wooden pieces inside of a bee hotel. And they are actually making their nest in these long cylindrical tubes. Now keep in mind that it's probably a good idea not to hang too many bee hotels in your backyard, because remember, the kind of bee that they're attracting are solitary bees. Mason bees, leafcutter bees. These are solitary bees. They're not used to being in areas with a lot of other bees. So, try not to have too many bee hotels, because if you do, there's always the possibility that you might be able to spread diseases among these bees, like the mason bees and the leafcutter bees. But it's an interesting project, so maybe you'd like to try it. Moving on to resin bees. The reason resin bees get the name resin is because, as I mentioned before when we talked about the cellophane bees, the resin bees also mix secretions, okay, from their abdomen and their saliva into a very resinous material, a very thick, viscous, resinous material that they line their nests with to protect their egg and larva. They like to nest in wood stems or stem cavities. They collect pollen on the bottom of their abdomen on their hairs. And they cap, as I mentioned before, they cap their nests. Once the eggs are laid, they cap their nests with this resinous material. They tend to be a little bit smaller than the size of a honeybee, and they're good pollinators of a lot of our native flora here in Michigan. The wool carder bees. The reason these bees get the name wool carder bees is because they are actually able to, with their mandibles, card plant hairs off of our plants and use those hairs, those plant hairs, to line their nest cavities with. The wool carder bees are solitary. They collect the pollen, again, on the bottom of their abdomens, and they like to nest in cavities either above ground or in wood. Now, not all of our wool carder bees in Michigan, however, are native. We do have 2 introduced species, and it's very possible that those are the wool carder bees that you will come into contact with. Wool carder bees are very common in urban and suburban settings. They tend to be a little bit larger than a honeybee, and they tend also to be a little bit more aggressive than other bees. They're very prone to chasing away other types of bees in their territory. They are fast. They are very fast flyers, and they're very loud. When they buzz by you, you definitely will hear them, and you'll say, "Oh, that was probably a wool carder bee." And they are very good pollinators as well, a lot of our native flora. Okay, let's talk a little bit about cuckoo bees. Now, cuckoo bees is a general term. It's not a specific kind of bees. Many of our bee families have cuckoo bees in them. So what cuckoo bees are is they're what we call kleptoparasites. And that is where they don't make their own nests. What they do is they visit existing nests of other types of bees, and they penetrate. They are able, with their abdomen, they're able to actually penetrate the brood cells of these other bees and lay their own eggs in the cells. And what happens is that when these eggs laid by the cuckoo bees emerge as larvae, the larva will then eat the larva of the bee that actually made the nest. So they destroy the host egg or larva, okay, when they themselves become larvae. So they're kleptoparasites. And they are involved, though, in the pollination of many of our native plants. But keep in mind that cuckoo bees can take on many different forms. It's their behavior that gives them the name cuckoo bees. Well, let's move on now into that family of bees that we are probably most familiar with, and that is the Apidae. And like I said before, that includes our honeybees and bumblebees and squash bees. So let's talk a little bit about bumblebees because, you know, there is probably no other more important native bee to pollination than the bumblebee. Bumblebees, they're social. They're social bees, like the honeybee. There are about 28 species of bumblebees in the eastern United States. Unfortunately, we're seeing a decline in the numbers of bumblebees, and that has dire consequences for crop pollination here in Michigan and the eastern United States. The pollen is collected in pollen baskets on their rear legs. Both honeybees and bumblebees have a slight indentation on their hind legs, and with long hairs. And with those hairs, they're able to collect large balls of pollen and use them to transport. Bumblebees like to nest in rodent holes, so they're usually ground dwellers. They're looking for pre-existing holes. Because of their size, they're going to be looking for a fairly good-sized hole in the ground to make their own nest. But they have been known to make nests in buildings as well. One thing about bumblebees is that they have very long proboscis or tongues. Okay, much longer than, let's say, a honeybee or some of these other native bees that we've talked about. And for that reason, they're able to drink nectar from many types of flowering plants that other bees cannot. They are, as I mentioned before, they are highly effective pollinists. They're generalists. They're not picky, but they are extremely important in pollination of all of our agricultural crops, including things like apples and cherries, plums, blueberries, cranberries, and also those members of the tomato plant family, things like tomatoes, eggplant, and peppers. Okay, so bumblebees are very, very important. Let's move on to the carpenter bees. We have both what we call small carpenter bees and large carpenter bees. Small carpenter bees would be a little bit smaller than a honeybee. Large carpenter bees would be the size of a bumblebee or even larger. Sometimes the large carpenter bees can be the largest species in an area. Both are solitary or semi-social. They may sometimes have 2 generations in 1 year, or even 3 in the case of the large carpenter bee, but oftentimes they just have 1 generation. They collect the pollen on their hind legs, and they nest in cavities. Well, in the case of the small carpenter bee, they like to nest in cavities in perennial dead woody stems, whereas the large carpenter bee, they like to nest in rotting wood or man-made structures. So if you have bees boring holes in the wood facing of your house or your garage or your barn, more than likely what you have are large carpenter bees. The small carpenter bee tends to be a generalist. It does frequent a lot of our native plants. The large carpenter bee also is a generalist and also frequents many of our native plants. Here's an interesting group in the Apidae, and those are the squash bees, because oftentimes we've talked, that a lot of these bees are generalists. They're not too picky about what plants they visit for pollen and nectar, but it's not the case of the squash bee. The squash bee specializes on cucurbits, which would be things like our squashes and our pumpkins. The females, they like to forage early in the morning, as soon as dawn. They're early risers, and they begin to start pollinating squash plants. Whereas the males, they tend to spend their evening, they tend to use the flowers of a squash and pumpkin flowers as like a hotel, and they'll actually reside in the flowers overnight. They are solitary bees. They will make their nest in the ground nearby any planted squash plants. Their nests tend to be deeper, deeper than a lot of other solitary bee nests. They collect the pollen on their long leg hairs, and they're about the size of a honeybee. In fact, squash bees look a lot like a honeybee. Okay, at this point we're going to move on and talk about the honeybee. Now, the honeybees are a member of the Apidae, just like the squash bees and the bumblebees and the carpenter bees we just talked about. What makes honeybees different, though, is that they're not native. The honeybee that we have here in the United States is the European honeybee. It was brought to this country way back in the 1600s by the early colonists because, number one, they wanted honey. Number two, they wanted wax to make things like candles. So it's an introduced species. They're not native. However, because they are very, very efficient pollinators and they're generalists, they are extremely critical to pollination of our agricultural crops, fruit trees, and also many of our native plants as well. So again, let's just take a quick look again at the anatomy of the European honeybee. I showed you this slide before. Again, remember, like bees, they have 3 main body parts: a head, thorax, abdomen, 4 wings, 2 forewings and 2 hind wings. And they tend to collect, they're very hairy. The hairs are forked, bifurcated hairs, which makes it very easy for pollen to stick to the hairs. And they will often accumulate most of the hair on their rear hind legs and to form those pollen sacs. One thing about social bees is that there is a division of labor. And it's very, the honeybee is a great example of how there is a division of labor. They are divided into what we call bee castes. There is one male bee caste and there are two female bee castes in a honeybee. So let's talk first up top. The top picture is a picture of a drone. Now, the drone is the name for a male honeybee. The job of a drone is basically to do one thing, and that is to mate with a queen. Sometimes they may help defend the hive from honey robbers, but basically the role of the male drone is to mate with the queen. Male drones do not have a stinger, so they're not going to sting you. If you're going to be stung, most likely it's going to be a female worker bee. They only have one set of chromosomes, and that's important. So since they only have one set of chromosomes, they're called haploid individuals. Whereas, people, we have two sets of chromosomes. We're diploid. The drone has a lifespan of about 90 days. Below the drone is a picture of a queen bee. The queen bee is a sexually mature female honeybee. These sexually mature bees can lay up to 1,500 eggs in one day. That's a lot. And unlike the drones and the worker bees, a queen can live anywhere from 1 to 4 years. However, once a queen passes the age of about 2 years, its productivity begins to diminish. But they can live to be up to 4 years. They produce scents called pheromones, and those pheromones are very important in attracting the drones and also for having worker bees accept and work for the queen bee. Under normal circumstances, there is only one queen bee in a hive. Now, there are rare circumstances when it's time for a queen bee, maybe to be replaced, or if a queen bee has been injured, and the bees may start producing another queen bee. But normally, under normal healthy conditions, there's only one queen bee in a hive. And they're raised in special queen cells, which we'll talk about in a little bit. At the bottom picture there, you see a picture of a worker bee. Now, first, let's look at the size of the three. As you can see, the queen bee is the largest in size of the three bee castes. The male drone is second in size, and the female worker bee would be the smallest of the three bee castes. The worker bees, the reason they're called worker bees is because they do all the work in a hive, basically. Well, with the exception of laying eggs. Obviously, that's the job of the queen bee. But just about everything else that goes on in a hive is done by the female worker bees. Now, there are specializations among the worker bees. For instance, some may be foragers. Foragers would be the ones that would go out, leave the hive, and gather nectar and pollen and bring it back to the hive. There are also guard worker bees. Those are the bees that guard the entrance to a hive to try to prevent other robbers from entering the hive and stealing honey, okay? Or in the case of cuckoo bees, laying their own eggs in the hive. Then there are those are the home workers, and those are the ones that take care of the queen and the larva, the eggs and the larva laid by the queen bee. So they're in charge of guarding, okay, and taking care of the larva. Then we have those that have housekeeping duties, You know, bees do die within a hive. You know, you have to think that one beehive, which I'll show you pictures later, they could easily have you know, over 100,000 bees in that hive, and bees do die, and it's important that dead bees are carried out of the hive, okay, and deposited just outside of the beehive, and so we have bees that worker bees whose job is to do that. And then we have those worker bees whose job is to produce the honey. So later in the presentation, I'll talk to you about how honey is made from nectar. But we have specialized worker bees in the hive that will take the nectar and start turning it into honey. Whereas the queen bee will lay fertile eggs, okay, the worker bees, the female worker bees, will lay sterile eggs. They can live anywhere from 2 to 6 months. It depends on what time of the year that the worker bee emerged from its cell. Just a little bit about honeybee genetics, because you know, maybe this could be a little confusing, but you know, it's important to try to understand why is there social behavior in the honeybee and certain other bees as well. What makes them social in nature as opposed to solitary or semi-social? And it has to do with genetics. You know, I mentioned before that the male honeybee, the drone, is a haploid organism. It only has one set of chromosomes. Okay, and you can see that in the diagram. You see at the top there, the second bee, that is a male drone, and it only has one set of chromosomes. Now, the queen bee has a full set of chromosomes. It's diploid, okay? It has 2 sets of chromosomes. So what happens is when the female queen bee mates with a drone, they produce worker bees, and the genetics of the offspring of the mating between the male and the queen bee result in worker bees that are more similar to each other. In other words, the sister bees are more similar to each other genetically than they are to their mother, the queen bee. And that helps explain why these worker bees work so hard to take care of the queen's eggs and larvae and help each other within a hive. It's because they actually are more genetically identical to each other than they are to their mother. Also, keep in mind that sometimes a queen bee may lay an unfertilized egg. And in that case, when that egg develops, it will become a drone. So drones, like I said, are diploid, and that is because they come from unfertilized eggs from a queen bee. Here's a picture of a honeycomb, part of a honeycomb. And you can see these are worker bees, and they're very busy doing various things. If you see those honeycombs that are filled with a brown substance, those are filled with pollen. And pollen is essential to the nourishment of bees in a beehive. So you have some cells that are packed with pollen. Those are those brown cells. And then you have those other ones that look kind of dark and clear, and those are brood. Those are brood cells. Those are cells where the queen bee has actually laid an egg, and now you can see the worker bees depositing jelly into those cells for the nourishment of the egg and then later the larva. So if we were to look at kind of a cross-section then of what a honeycomb looks like, that's the picture on the left there. You can see that most of the eggs that are going to be laid by a queen bee are going to be fertile eggs. They are going to turn into worker bees, female worker bees, and that's the majority of the brood that you're going to find in a beehive. Over in the lower right-hand part, you can see there are a few drone cells. Okay, So the bees that will emerge from the drone cells will be male drones, okay, and they come from unfertilized eggs. What's really interesting, though, is a queen cell. Now, as I mentioned before, there's typically only one queen in a hive, but sometimes it may become necessary to start producing a new queen for the hive. And queen cells, as you can see, are extremely large. They oftentimes are found on the bottom of a frame or in between frames in a hive. And as you can see, the queen cells are extremely large, and they're easy to spot. So when you see those, you see that, oh, they're trying to make a new queen. Now, usually they will try to make more than one queen. You may see 2 or 3 of these sometimes in a hive. If the queen is healthy, the queen will destroy the larva in the queen cells. However, let's say the queen is injured, or the queen has left and died, or left because it has swarmed, or maybe it has died. There may be 2 or 3 queen cells, and the first new queen to emerge from one of those cells will then destroy the other 2. So there's only one queen in the hive. A little bit about metamorphosis in bees. Bees are a type of insect that undergo what we call complete metamorphosis, which means they have 4 stages to their life cycle. They begin as an egg, they then develop into a larva, they then pupate, form a pupa, and then finally they become an adult. So how many days a queen or a worker or a drone exists during one of these stages, life cycle stages, varies. Whether you're a queen or a worker or a drone, all of them will lay an egg, and the egg will remain an egg for 3 days. However, then things change depending on the bee caste. In the case of a queen, the egg will then develop into a larva, and the larva will last for about 5.5 days. In the case of a worker bee, the larva will persist for about 6 days. And with drones, it's about 6.5 days. So it's close. They're within about a day of how long that bee caste remains as a larva in the larva stage. After the larva stage, the larva then pupates, becomes what we call a pupa. And in the case of a queen bee, the pupa lasts for 7.5 days. In the case of a worker bee, it's 12 days, much longer. And in the case of a drone, it's even longer, 14.5 days. So the total time from egg laying to becoming an adult varies. For a queen, it's only 16 days. In the case of a worker bee, it's 21 days. And in the case of a drone, the male bee, it's 24 days.